Okay, so we're gonna start by going over these. Like I said, these are the same ones that were on the back page of your quiz yesterday, and I'm not even gonna bother grading those. I shouldn't have put them on there. I should have waited till today to go through these. So like I was saying at the start of class, last week, I told you we were gonna do the hardest thing we'd do all year. And this was on page 21. Could you guys all turn to page 21 in your packet? If you don't have page 21 done because you weren't here, or if you were here and you weren't paying attention and you don't have 21 done. Now we didn't do, oh wait, ignore that line, we did do that. We didn't do some of these on the bottom. We didn't do these three. So if those are blank, that's okay. We didn't do these three. So if you didn't do those, that was okay. And we didn't do this side. So that's okay. So we did do that first side up there. So if you don't have the rest of this page filled in for whatever reason, you need to go back into Teams, and I posted the videos, I posted the lesson and what was for homework those days. This, I believe, we started this on Thursday. So that would have been Thursday the 9th. And then we finished it up on Friday on page 22. Again, if you don't have this top section and half of this chart, so we did not do this side. If you did not have that done, then you need to catch up on that from the notes on Friday. We did not get to all of these down here, so that's not something you're missing. So every time we did these, I said they were the hardest thing we were going to do all year. And then every time we did them, you guys are like, that wasn't so bad. Now we're going to put them together. And this is where I personally think they get a little harder, is when I'm asking you to put everything we did and try and figure out what you have to do. So one thing that I would like you to do in your notes is label this section up here. So state how long it takes for P waves and S waves. We're going to label that. I've used a Roman numeral 1 because we got lots of other ones around. So I'm going to use a Roman numeral number 1 there. Thank you. And so that was like the first thing we did. Then this section is the second thing we did. This is the third thing we did down here. And then on page 22, this stuff right here was the fourth, and 4 in Roman numerals is IV. That's not important. So we did 4 different types of activities on the last 2 days we were here. They correspond to these questions 1, 2, 3, and 4. So if you need to go back in your notes, this is number 1. This question here is number 2. This one goes with section 3, and this one goes with section 4. So I just put in order the way the Regents is going to ask these questions. So let's see how you did on these. So it starts with state how long it takes the P and S waves to travel 6,000 kilometers. So the first thing you needed to see there is it said state how long it takes the P and S waves. So that means you're going to need an answer for P and an answer for S. So you need 2 separate answers here. So we have to go to our reference table, and I did give you either the enlarged copy of the reference table. So that one is easier for some people to use, or you just have your regular reference table. I apparently have no idea where mine is. Might be using the big one. All right, I'm just gonna I'll go with my blue one here. So it starts with state how long it takes the P and the S waves to travel 6,000 kilometers. So to do this, so it just says state how long it takes to travel. Remember, this reference table, we used it 2 different ways. We did the up and over, and then we did the scrap paper stuff. So this is just an up and over. So whenever it says travel just means use your reference table the way it's intended to be. So you go to 6,000, you go up till you hit the P, and you read over. So I see that the P is one line above the 9. So, and it could have been a little bit more than one line, but I said it was 9 minutes and 20 seconds. Then you needed a whole second answer for the S wave. So still to the 6,000, read till you, whoops. Read till you hit the line, read over. That one was right at 17 minutes. For this, I would give you 10 to 20 seconds, either higher or lower. So in that case, if you had said 9:10 or 9:30, you're still okay. If you said 17:10 or 16:50, you're okay too. How'd you guys do on that one? Okay, now the next one again says state how far the P and S waves can travel in 6 minutes and 40 seconds. So any time you see travel, and you might want to put this either in your notes, or if you're going to keep this in your notes, when you see travel, you're just going to do either the up and over method or the over and down. So by up and over, I mean what we just did, you go up till you hit the line and read over. Or for this one is the over and down, meaning we go to 640, go over till you hit the line and go down. So I gotta do that a little more carefully. So for that one, I got halfway in between the 2, 4, 6, 3,600 and 3,800. So for the P, I said 3,700 kilometers. And for the S, I got to redo it. So 640, hit the S, that's 1,800. So again, anytime you hear travel, that's what I call the easy ones. No scrap paper involved. But once we start seeing difference in arrival time, that's where you have to grab your scrap paper and do your scrap paper stuff. So these are like steps 3 and 4 that we did on Thursday and Friday last week. So step 3, we did have a whole set of directions here, so I didn't copy them into my notes. But all those steps are how you figured out determining the difference in arrival time. So if you recall, step 1 said, you take your scrap paper and you line it up with that distance, so 4,200. So you find 4,200, line your scrap paper up. Mark your scrap paper. And then you pull it over to the X or the Y axis and just read the time. So I get a little higher than 5 minutes and 40 seconds, about 5 minutes and 40 seconds. So you mark the P and the S wave and you bring it over to the time. Then the fourth thing we did as we wrapped up Friday was determining the distance if we know the distance in arrival time. So we know the distance in arrival time was 4 minutes and 20 seconds. So that's when you take your scrap paper. You mark the 0 and the 420 and you slide it up to see where it fits. Mine looks like it's fitting pretty good at 3,000, so I'm going to take it up half a box. See if it fits a little. I'm just going to double check here. Looks like I made mine too high. So 420. It looks like it fit pretty good at 3,000, but I'm just going to double check half a box smaller, and it does fit half a box smaller. So I say that is 2,900 kilometers. So for those of you who did it, how'd you do? Not too bad. What did you have? What made it not perfect?
It was just
Okay, so now you see the key words, hopefully. So travel is the up and over, and you need 2 answers. And when you see arrival, I want you to picture me picking up a piece of scrap paper and hitting you across the face with it, okay? Anytime you hear arrival time, just think of me aggressively slamming scrap paper at you because you need to do the scrap paper stuff. You know how to do both methods. It's just deciding when you do each one. That's when this gets hard. Now we have to move on to the fifth and final way that they're going to ask these questions, and that's question 5. Question 5 gets weird. This goes along with question 4. Question 4 and 5 are almost identical. Question 4, I say, hey kid, the difference in arrival time is 4 minutes and 20 seconds. What do I do different in the question 5? Go ahead and read question 5 and see how I worded that differently. I don't say, hey kid, the difference is, what did I do? Isn't that what I did in question 4 though? How did I do it differently? This question 4, I give a time and I want to know how far away it is. How did I word this slightly different to make a new level of question? Okay, so in question 4, I literally tell you the difference is. Question 5, I change it up and I say the P wave arrived at 2:53:26 and the S wave arrived at 3:02:12. What do I mean by 2:53:26 and 3:02:12? Yeah, that's the time on the clock. I'm telling you at 2 o'clock, well, 2:53:26 on the clock, and then 3:02:12 on the clock. That's when they got there. So imagine sitting in your classroom or sitting at your house at 2:53:26, you feel the P wave, and then at 3:02:12, you feel the S wave, and your question is, how far away was that earthquake? That's what this question is. So what do we need to do to make it like question 4? Question 4, I told you the difference is 4 minutes and 20 seconds. We do need to subtract them. I need to know the difference before you can go and do the scrap paper stuff. So difference means subtract. So we have to subtract these times. Subtracting time can be messy. Before we subtract time on this one, which I think is harder, I'd like you to go to page 22. Nope, 23. I believe here in third period, we did start page 23 already on Friday. All right, so I gave 3 examples here on page 23, and I'm pretty sure we already did question 1, but let's go through it one more time. It says a seismic recording station recorded an earthquake's P wave at 20 seconds after 1, and the S wave arrived shortly after at 1:04:40. How far away is the epicenter? So before we can do the scrap paper stuff, we need to know the difference. So difference means subtract. When you're subtracting time, it can get weird. And I need you guys with me and trying this out with me. Even though example 1 and 2 are pretty easy, even question 3 is pretty easy, I need you to work with me on these so that you can see when we get to harder ones like question 5 in that quiz, you'll see that it gets a little harder. So to subtract, there's no such thing as negative time. Ever. So we always put the bigger number on top. Which wave is always going to be the bigger time? Why the S? Because it goes slower. So its time is always going to be bigger. So to do this, we always put the S on first. And in this example, it was 1:04:40. And then we put the P. So this one was 1 hour, 0 minutes and 20 seconds. This one's super easy to subtract. So when you subtract these, in math, where do you always start from when you subtract? The far right. So you start over here and subtract. So 0 minus 0 is 0. 4 minus 2 is 2. 4 minus 0 is 4, 0, and 0. So 4 minutes and 20 seconds. And again, we already did that in class, I think on Friday, because I think there was some giggling. I remember now. Now, if we know the difference in arrival time is 4 minutes and 20 seconds, how do we figure out how far away the earthquake is? The difference in arrival time. When I say difference in arrival time, what do I want you to picture? Aggressively slamming scrap paper in your face. So grab a piece of scrap paper. I don't have any more pieces cut up. So it's literally any piece of paper that you have in your binder. Yes, you can use, use the quiz that I just handed out. Never mind. Use the quiz that I handed out. You don't even need to use the back. You have all the sides work perfectly fine. So we're going to just use the quiz. You know what to do when you have a difference in arrival time and you have to use the scrap paper. The only thing I gave you was 4 minutes and 20 seconds. So do we start on the left or in the middle? The left. When I give you a time, you have to start with your scrap paper at the time side. So again, do the scrap paper stuff starting with your scrap paper on the left. I'm going to come around and make sure you guys know what you're doing. So you need to have this up in front of you. And just like you did in the last example, I got the 0 and the 4. Start with that. Go ahead, Jonah. You got this. Nope, you will not. Okay, so just that was hopefully just a quick refresher from last week there. You mark off the 0 and the 420. Remember, these go up by 20 seconds. Then you slide it up and over until you find where it fits perfectly in between the P and the S waves. So for those of you who are stuck here, I get it pretty darn close at the 3,000 line, but it's not perfect. What was my hint for you there? If it's, yep, I want you to slide it each way half a box. When I slide half a box down, so if you remember, the boxes go by 200. So if I'm half a box before 3,000, I'm at 2,900. Let's try the next one. I saw a few of you go ahead, and that's okay, but I would like you now to come back to me and double check that you did example 2 correct. So example 2 is the same as example 1, just with different numbers. It says it recorded the P wave at 10:08 and the S wave at 10:15:40. So again, you always put the S wave on top. And then we've got now, I'm going to give some helpful hints when subtracting time just to make your life easier. I know when you subtract normally, if you had 1,540 minus 1,000, nope, sorry, match those up wrong. 10, 15, 40 minus 10, 08. I know if you had this number, what's the first thing you would do? We're going back to elementary school here. What's the first thing you would do? You would do the whole, no, what would you do back second grade? 0 minus 0, right? 4 minus 4, right? Or 4 minus 0. Now, what would you do here when you get to, you borrow. So you can't do 5 minus 8. So you borrow, you come over here, you change this to a 0 and you change this to a 15. And 15 minus 8, which some of you might need to use a calculator for, and I'm all for using calculators. Please don't mess up simple math. That's 7. Then you go 0 minus 0. Sorry, 0 minus 0 and 1 minus 1. So you got a difference of 7 minutes and 40 seconds. It pretty much works the same, except for when you're doing time. You can't just go borrowing all over the place. The first thing I want you to do is instead of going 0 minus 0, I want you actually to do what Tyler said originally. Keep these in groups. Keep the seconds as a group. So instead of doing 0 minus 0, I want you to think of that as 40 minus 0. And instead of 5 minus 8, I want you to think of this in a group of 15 minus 8. And instead of 0 minus 0 and then 1 minus 1, think of that as 10 minus 10. This one works out really nice still. So 40 minus 40 is 40 minus 0 is 40, 15 minus 8 is 7, and 10 minus 10 is 0. So we get a time difference of 7 minutes and 40 seconds. Go to your reference table. Tell me how far away the earthquake is. So it's literally exactly the same as the last one. Mark off your 0, mark off your 740, slide it up to see where it fits. What'd you get? Okay, I got 6,100, so 62 works, or 6,000 works, or 6,100. 64 seems a little big. My guess is that your lines were just maybe a little fat, or you didn't have your paper perfectly lined up, but you're still within, well, you're within 300 of mine. You're probably okay. We'll just keep an eye on it, okay? Yeah, okay, so that's within 200 of mine. Again, we'll just keep an eye on that. If it keeps happening, I'll come over and check to see what you're doing that is a little off from me. All right, example 3 is where it gets a little hairy. And again, I would like you, even if you got this already, this is an easy, hard one, if that makes any sense. This is pretty easy compared to what we could be getting. So it starts with example 3, a seismic recording station recorded an earthquake's P wave at 3:59:40 and the S wave arrived shortly after at 4:05:40. And the P wave again was at 3:59:40. I'm gonna actually come to the scrap paper just so I can write this larger so you can see where this gets a little weird. So again, the example was 4:05:40 minus 3:59:40. And you need to find the difference. And like I said last time, I don't want you to do 0 minus 0 and then 4 minus 4. I want you to think of it as 40 minus 40, 5 minus 59, and 4 minus 3. So I'd like you to keep them in bunches. which makes that first one still pretty easy. What is 40 minus 40? Obviously, that's 0. But now we get to 5 minus 59. Now, okay, some of you are able to count this because this is an easy one, but I want to show you how to really do this. Yes, the answer is 6, but I want you to see how this really gets done. So can we do 5 minus 59? No, just like we couldn't do 5 minus 8. We can't do 5 minus 59. So what do we have to do? Borrow. Here's where borrowing gets a little weird. When I go over to the 4, what am I really borrowing? What is that placement? It's not hundreds, this is time. What? Hours. Remember, this is hours, minutes, and seconds. So when I come over here to the 4 and I borrow an hour, just like in normal math, that reduces to 3. But because I borrowed an hour, how many minutes did I borrow? 60 minutes. Now, so in normal math where you would just change it and add that 10 out front, here you can't always just add a 6 out front. You have to add 60 to whatever's already there. So I already have 5 minutes. I'm adding 60 seconds to it. This changes to a 65. Now you can do 65 minus 59, which if you need to use a calculator, go for it. Or like Jake said at the beginning, that's 6. 59 or 65 minus 59 is 6. This one you can do different, but you can't do them all different. Let me find one that you can't do easily. Let's switch to page 25. Are you having flashbacks there on page 25 of elementary school and your timed frequency test or whatever, their fluency test? Yeah, we're not going to do all of these. I want to do, I'm going to try and pick a hard one. Let's do question 7. Right here on page 25, we're going to do number 7. And again, I'm going to rewrite it so it's nice and big so everybody can see what I'm doing here. So we're doing number 7. I'm just going to rewrite it. 205, 17 minus 155, 34. So this one, it's not as easy just to count it out, which is what you guys who said you did it differently did. So again, I want you to don't do 7 minus 4. Keep it in a bunch. Can we do 17 minus 34? No. So we are going to come over. We're going to come over and borrow a minute. So we're going to change this from a 5. What does this get changed into? Just do one step at a time. I know some of you are going to try and do more, but just get changed into a 4. Now we borrowed 1 minute. How many seconds did we borrow? 60. How many are already there? So we have 60 plus 17 is 77. So this changes to a 77. So again, all I did was add 60 to what was already there. Now you can use your calculator or just do this off to the side. 7. Now over here, this is all normal math over here. 7 minus 4 is 3. 7 minus 3 is 4. So this is 43. So 77 minus 34 is 43. Now can we do 4 minus 55? Nope. So you got to go borrow an hour. So the 2 changes to a 1. What does the 4 change into? 60, nope, 64, because it's already a 4, and I'm adding 60. So this changes to a 64. 64 minus 55 is 9. Again, that you can either do in your head, off to the side, or with a calculator. So number 7 is 9 43. Your homework. No, let's do a total of 8 of those. So you have 7 more to do. Any 7.
You can't use a calculator.
So, right, you can't just plug this into your calculator. Like I can't do what we just did at number 7. I can't do 205.17 minus 155.34. Doesn't give me a real time. So you have to do this the way I just broke it down. Which one is easier? There's a couple easy ones in each row, but some of them are harder. Like some of them you don't have to borrow. Check out this first one. 50 minus 25, you don't have to borrow. 9 minus 8, you don't have to borrow. So don't get over borrowing. Just take it bit by bit. So your homework is page 25. Do 8 of them. Do any 8. If you haven't already turned in the quiz, make sure I get that for a late grade. Bring back this paper we were working on. Bring that back tomorrow. We're going to do question 5 at the start of class tomorrow.